Lesson 1E, we're going to look at radicals, simplifying them, and multiplying expressions that have radicals in them. Okay, so square root, remember that is the number that when you multiply it by itself is equal to whatever number is under the radical. This is a square root symbol. It is a radical. All right, in later classes you will learn about other roots. We're really just going to talk about square roots. Okay, so the square root of 49. That would be 7 because 7 times 7 equals 49. The square root of 100 would be 10 because 10 times 10 equals 100. The square root of 12, if you were to put that in your calculator, you would get a decimal number because there is no whole number that when I multiply it by itself, I get 12 as the answer. However, we are not going to accept decimal answers, so you need to simplify that radical, and there are two choices. Okay, so first choice is to rewrite with perfect squares. So first, let's make a list of perfect squares, and I like to start at the top with the higher number. So 10 times 10 is 100, so 100 is a perfect square. 9 times 9 is 81. 8 times 8 is 64. And I want you to pause and continue making this list. Okay, so this is 8 times 8, so the next one would be 7 times 7. Okay, so this is my list of perfect squares, and I am looking for which one of these can go into 12 evenly. So if I'm going to simplify the square root of 12, I'm going to break it apart as a perfect square times something that equals 12. Well, I know I can divide 12 by 4. So I'm going to rewrite the square root of 12 as the square root of 4 times the square root of 3, because 4 times 3 would give me 12. And then this is a perfect square, so I can simplify it. The square root of 4 is 2. So the square root of 12 simplifies to 2 square root 3. And I know that I'm finished because 3 cannot be divided by any of these perfect squares over here. Alright, so that's the first method. The second method is to use something called a factor tree. So that's where I'm going to take the number 12 and I'm just going to divide it by something. Okay, I know I can divide 12 by 4, so it would be 4 times 3. And I know I can divide 4 by 2, so it's 2 times 2. And there's nothing I can divide 3 by except for itself. So my factor tree is finished, and now I'm going to look for pairs. I have a pair of 2's, so that means in my final answer, 2 goes outside the radical. And then whatever is left over, so over here I have a 3, 3 goes inside the radical. Okay, so either method, if done correctly, will give you the same answer. So you get to choose. I have absolutely no preference which one of these you pick. Pick the one that makes the most sense to you so that you're going to do it right every time. Alright, so here we have 3 more examples. So I will do 45 both ways. So the square root of 45. 45, the perfect square that I can divide 45 by is 9. So this is the square root of 9 times the square root of 5, because 9 times 5 is 45. The square root of 9 is 3. The square root of 5 is as simplified as I can get. So that 3 square root 5 would be my answer. Okay, the other way to do it is do my factor tree. So 45 I can divide by 5. So that's 5 times 9. 5 is prime, so I'm done on that branch of the tree. 9 is 3 times 3, and both those 3's are prime. Here's my pair. So my pair goes outside the radical. My leftovers go inside the radical. Alright, I want you to pause here and try this, the square root of 72 and the square root of 42. You use whatever method you want. I'm going to write down both methods so that you can check your answers in a second. Okay, here are the answers for 72. Okay, hopefully if you did your factor tree, you will see that we have 2 pairs. I have a pair of 2's and a pair of 3's. Anytime that happens, you're going to multiply those 2 numbers. So 3 times 2 gives me 6, and then I have the 2 here that's left over that stays inside. You would do the same thing if you had other leftover things inside. So let's say like I had another random like 5 over here. I would do that times 5 inside the radical, and it would give me 6 square root 10 as my answer. Okay. The square root of 42 is as simplified as it gets. There are no perfect squares that I can divide 42 by. Okay, if you make a factor tree, notice we have 2, 7, 3. There are no pairs. Okay, so that means it is already simplified. It would just be the square root of 42. Alright, and then we're going to throw some variables in there, because why not? Okay, a variable with an exponent is a perfect square if that exponent is even. Okay, and you take the square root by dividing by 2. So here I have the square root of x squared y to the 4th. The square root of x squared, I'm going to divide this exponent by 2. Alright, so 2 divided by 2 is 1. So I have x y to the 4th. If I divide the exponent by 2, that gives me y squared. So this is the square root of x squared y to the 4th. Alright. Here, we're going to put the two concepts together. So I have a number, and I have x to the 3rd. So how I'm going to split this up is the square root of 9, because that is a perfect square, so I'm not going to mess with that. Alright, and then I'm going to change this to give me a perfect square. So in x to the 3rd, I'm going to reduce that number by 1. That gives me x squared, and then I have 1x left over here. So now when I simplify, the square root of 9 is 3. The square root of x squared is just x, because I divide the exponent by 2. And then I'm left with the square root of x that cannot be simplified any further. Alright, same thing here. So 8. I can break 8 apart into the square root of 4 times the square root of 2. Alright, x to the 6th is already an even number, so I'm going to leave it. And then my y, I'm going to break apart into y to the 6th times y. I just want this to be an even number. That's how I'm breaking these exponents up. Alright, the square root of 4 is 2, so I took care of that one. The square root of 2 cannot be simplified. The square root of x to the 6th, remember all I'm going to do is divide this exponent by 2. So that would be x to the 3rd. Alright, the square root of y to the 6th is y to the 3rd. So I took care of that. So what I have left over that cannot be simplified in my radical is 2y. And that would be my final answer. Alright, final thing we're going to look at is multiplying radicals. Okay, so you have the steps there. What I like to say is outside times outside, and then inside times inside, and then we simplify just like we've been doing throughout this video. So here, outside times outside, 3 times 4 is 12. Inside times inside, 2 times 5 is 10. Then we would have to see if we can simplify. Now, to simplify the square root of 10, alright, I can only divide 10 by 5 and 2, and neither of those are perfect squares, so this one is done. Okay. If I move on to the second one, outside times outside, 9 times 5 is 45. Inside times inside, 2 times 6 is 12. Okay, that 12 I can simplify. So I'm going to have 45 times, and 12 can be broken apart as the square root of 4 times the square root of 3. Then I can simplify. The square root of 4 is 2. So now I have 45 times 2 times the square root of 3. 45 times 2 is 90, so I'm going to have 90 square root 3, and that's going to be my simplified answer. Okay. Last one here, even though there's 3 of them, it's still the same. So outside times outside times outside. So 4 times negative 8 would be negative 32. Negative 32 times 2 would be negative 64. And then inside, I have 3 times 15 times 2. Alright, 3 times 15 is 45. 45 times 2 is 90. And then I need to simplify. Alright, so the square root of 90, I can break that apart as the square root of 9 times the square root of 10, because 9 is the perfect square that can be divided in there. Alright, negative 64 times the square root of 9, which is 3, times the square root of 10. And then my last step is going to be negative 64 times 3, which is going to be negative 192 square root 10. That is as simplified as I can get it, and that is it for radicals.